Hello viewers and welcome to this channel. Let's go through section 2 of KCSE Mathematics 2025. I have already uploaded section 1 of this paper. You can check it in the recent uploads. Don't forget to go to the description of the video too to get the link to download the question paper so that you can try to solve the questions first before going through the video. Let's go to question 17. Two varieties of groundnuts, type Q and type R, are sold in the market. Type Q is sold at 130 shillings per kg, while type R is sold at 180 per kg. Part A, a trader bought 50 kg of type Q and 75 kg of type R from the market. The two varieties were mixed. Part 1, determine the cost price of 1 kg of the mixture. So we have two varieties of groundnuts. We have type Q and then we have type R. Type Q is sold at 130 per kg, so 130 per kg, and type R is sold at 180 per kg. The trader bought 50 kg of type Q, so 50 kg for type Q, and 75 kg of type R from the market. Then the two varieties were mixed. So you're required to get the cost price of 1 kg of the mixture. So this is how you're going to get the cost price. So the cost price will be given by, we start with Q. We have 50 kg and 1 kg costs 130. So what about 50 kg? So you're going to get the cost by taking 50 kg multiplied by the cost of 1 kg, which is 130. We multiply, because we're getting the mixture, we add for type R. 1 kg cost 180, there's 75 kg, so 75 multiplied by 180, like that. And then from there we divide by the total mass now, because you're getting the mixture. So 50 kg plus 75, so 50 plus 75, that is how you get the cost price of 1 kg of the mixture. So this will give, when you work out this using a calculator, 50 multiplied by 130, then plus 75 multiplied by 180, that gives 20,000. You get 20,000, and then you divide by 50 plus 75, that will give 125. When you divide these, you will get this one to be 160 shillings. So that is the cost price of 1 kg of the mixture. We go to part 2. The trader sold 80% of the mixture at 170 per kg and the rest at 180 per kg. Determine the percentage profit made by the trader. So the trader sold 80% of the mixture at 170. Now what is the mixture? The mixture is made up of, remember, type Q has 50 kg. Type Q has 50 kg. So total mass will be given by Q, we have 50 kg. Then R, there is 75 kg. So this gives a total mass of 125 kg. So this trader sold 80% of these 125. So 80%, which is 80 over 100 of 125, which costs 170. So the trader sold 80% of the mixture. So 80%, the mixture is 125 at 170, like that. So that will give us the selling price of the 80% of the mixture. And then the rest will be 20%. So if the trader sold 80%, so what remained is 20%. Just take 100% minus 80%. So what was left was 20%. So 20% of the same mixture, 125. This one was sold at 180 per kg. 180. So this now will give us the total selling price. So use a calculator to work out this. 80 multiplied by 125 times 170, everything divided by 100, that gives 17,000. Then plus 20 multiplied by 125 multiplied by 180, then you divide by 100, that gives 4,500. So this gives a total of 21,500. 21,500. So this is the selling price. So that is the selling price. What else are we required to get? We are supposed to determine the percentage profit. So how do you get the percentage profit? Percentage profit is given by profit divided by the buying price times 100%. So we need to get the buying price. What will be the buying price? The buying price, we are going to get it from, we have it somewhere here, the buying price. So from the cost price, look at the cost price. We got the cost price of 1 kg of the mixture. We got that, the cost price of 1 kg of the mixture. It was 160. And we have the total kgs, the total mass was 125. That is where we get the buying price. So whatever we got in the first part was the cost price. This is what we take as the buying price. So we had 160. So let's go to the cost price. We got it as 160 shillings per kg of the mixture. And how many kgs were these? The kgs for Q was 50, then the kgs for R was 75. So the total mass is 125. So 1 kg cost 160. What about 125 kg? When you multiply these, you get 20,000. So these will be the buying price, or simply the cost price. With this now we can get the profit. We can get the profit, and then we get the percentage profit. So percentage profit is given by profit. Profit, you take the selling price, which is here, subtract, take the selling price, which is 21,500, subtract the buying price or the cost price, which is 20,000. Then we divide by the buying price, which is still the cost price, like that. And then everything here should be multiplied by 100%. So this gives 21,500 subtract 20,000, you get 1,500 divided by 20,000 multiplied by 100. When you work out this one using a calculator, 1,500 divided by 20,000 multiplied by 100, this gives 7.5%. So that is how you're supposed to determine the percentage profit made by the trader. We go to part B. Another trader bought and mixed the two varieties of groundnuts. The trader made a profit of 25% by selling the mixture at 200 per kg. At 200 per kg. Determine the ratio in which the trader mixed the two varieties. So the first thing we are going to get is the cost price. We are given from this statement, the trader made a profit of 25% after selling the mixture at 200 per kg. So from there, we should be able to get the cost price if you're given the selling price. So these 200 shillings represent 125. That is after making the profit. The cost price is 100%. Then after making the profit, it will be 125%. So 125% represents 200 shillings. So what about the cost price of these 1 kg of the mixture, which is 100%? What about the cost price, which is 100%? So this one will give you 100, just cross multiply, times 200 divided by 125, and this one gives the cost price to be 160. So now after getting the cost price, that will assist us in getting the ratio. When you're getting the cost of 1 kg of the mixture, this is what you're going to do. Remember, we have in the first part, so we have the varieties. The variety Q was selling at 130. So Q, this variety Q was selling at 130, and then R was selling at 180, like that, shillings. And now, because we don't know the ratio, we can let the ratio in which the two are mixed, the ratio in which the two are mixed, to be X is to Y, whereby X will represent the X variety and then Y for the R variety. So we have the cost, the selling price here. We're given from the first statement. The type Q is sold at 130 per kg and R is sold at 180 per kg. That is why we got 130 and 180. So now, getting the cost, because we already have the cost price of 1 kg of the mixture, we get it by, we take 130 multiplied by X, 130 multiplied by X, plus 180 multiplied by Y, and then we get the sum of the ratios, which is X plus Y, and these should give the cost price of 1 kg, which is 160. So from here, we can simply we can cross multiply. You can just put this on over 1 and then you cross multiply, so that you get 130x plus 180y is equals to 160x plus 160y, like that. So that is what we should get. Then from there, I can simply decide to take the like terms to one side, so that I have 160x here, 160x, subtract 130x, like terms on one side, and then on the other side can have 180y, can have 180y, subtract 160y, just putting the like terms together. So 180y subtract 160y, you get 20y, and then 160x minus 130x, 160x minus 130x, this one will give 30x. Because we want to get the ratio x is to y, can simply divide these both sides by 30, and when you divide both sides by 30, you will get 2 thirds y is equals to x. And since I want to get the ratio x is to y, I can divide this side by y and this side by y too, so that I end up with 2 thirds is equals to x divided by y, and this x divided by y is the same as x is to y. Then 2 divided by 3, can write it as 2 ratio 3. So now we have the ratio. So the ratio is supposed to be 2:3. So that is how you're supposed to solve that question. Question 18. Registering for a music club cost 7,000 Kenya shillings, while for a mathematics club cost 7,200 shillings. The registration cost is shared equally among members of each club. Originally, both clubs had X members each. However, before payment for registration, 5 music club members switched to mathematics club. Part A of the question: write an expression in terms of X for the amount contributed by 1. Each music club member after the switch. Each music club member after the switch. Now for the music club members, it costs 7,000. That is the total. So for us to get the amount contributed by each music club member, we shall take the amount that they were to contribute, all of them together, which is 7,000. And then we divide by the number of members. So originally they were X members each, but after the switch there are 5 members who switched to mathematics, so therefore the new members will be X subtract 5. X subtract 5. They were originally X members, so after 5 left, the ones who are left are 5. So this is the expression that will show the contribution of each music member after 5 members left. So take the total amount they were to contribute, divide by the number of the members. Then part 2, each mathematics club member after the switch. So after the switch, we do the same. We get the total amount that was to be contributed by the mathematics club, which is 7,200. And then we divide after the switch. Remember, originally both of the clubs had X members, so 5 moved from music and joined mathematics. So in mathematics, the new members now are X plus 5, the one who switched from music. So now this is the expression to show the contribution of each mathematics club member. We got part B. Given that a music club member contributed 40 shillings more than the maths club member, form an equation in X, hence determine the value of X. So if the music club member contributed 40 shillings more, so to form an equation using the two expressions here, because we have the expressions to show the contribution by each music member and each math member, we shall take the contribution made by each music club member, which is 7,000 divided by X minus 5, 7,000 divided by X minus 5, and then when we subtract the contribution by each maths member, which is 7,200 divided by X plus 5, that should give us 40. Why? Because the music club member contributed 40 shillings more than the mathematics club member. So if I take the amount contributed by each music club member, then subtract contribution by each maths member, I should get 40. That is the equation. Now we should solve these. How do we solve these? There are several ways of solving these. I will first get the least common multiple of X subtract 5 and X plus 5. So the LCM, which is X subtract 5, X plus 5, that is the least common multiple. Then multiply each term by that. So we have 7,000 divided by X minus 5. You multiply that one, X minus 5, X plus 5. And then you have the other one, which is 7,000, was you subtracting 7,200 divided by X plus 5. Again, you multiply that by X minus 5, X plus 5. Each term, you multiply each term by that. And this one should be equal to, that should be equal to 40. And then 40 you multiply by the same. So you multiply by the same, X minus 5, X plus 5. So multiply each term by the LCM. So when you do that, these are x minus 5 will divide out, and then x plus 5 here is going to divide out, so that you'll be left with, here you shall have 7,000 multiplied by x plus 5. Then here you shall have 7,200 multiplied by x minus 5 is equals to 40. Then when you expand these, x minus 5 multiplied by x minus 5, when you expand that, you'll get x squared minus 25. Now we can proceed and open the brackets. So this will give 7,000x plus, this will give 35,000. Then subtract 7,200 times x, that will give 7,200x. Then this negative 7,200 multiplied by negative 5 will give negative, that will give negative 36, positive 36, to give positive 36,000. Negative 7,200 times negative 5 will give positive 3,600 is equals to, this will give 40 x squared minus this will give 1,000, that will give 1,000. So now after getting that, the next thing, we can collect the like terms together. So when you look at this one, for instance, 7,000, let me just, so we have 7,000 subtract 7,200, that will give negative 200x. And then this one is 1,000. Before I forget, this is 1,000 here. And then we have 35,000. We have 35,000 plus 36,000. That will give 71,000. Will give 71,000 like that. Then I want to bring everything to, of course, let me see, the 71,000. Yeah, this is 71,000. Yes, okay. If I bring whatever is in the right hand side to the left hand side, I will have plus 1,000 and then minus 40x squared. So what I've done, I've simply taken this negative 1,000 to the left hand side by adding 1,000 to both sides, in other words, and that is what I got. Then I've subtracted 40x squared from both sides, so that on the right hand side I'll remain with 0. So this will simplify to negative 200x plus 72,000 then minus 40x squared. So you can see this one is forming a quadratic equation, so you can reorganize these to form a standard quadratic equation. So I will multiply each value by negative, this by negative, this by negative 1, this by negative, each value, so that I can get rid of these negative here. Multiply each value by negative 1, this by negative 1, this by negative 1, this by negative 1, so that you shall have now 40x squared then plus 200x minus 72,000 is equals to 0. Now after doing that, we can continue simplifying this one further. You can divide each of these by 40. Divide each of these terms by 40, and you will end up having something like this. You'll have x squared plus 5x minus 1,800 is equals to 0. Now that one is simplified. Now from here, you can use any suitable method to solve for x. You can use factorization method or use the quadratic formula. I prefer to use the quadratic formula. I'll use the quadratic formula to solve these. This is the quadratic formula that I'm writing here. You only need to identify what is A. So according to this one, A is 1, the coefficient of X, the B will be 5, and then C will be negative 1800. So A is 1, B is 5, C is negative 1800. So substitute these, you will have negative 5 plus or minus, then B squared is 5 squared 25 minus 4 multiplied by A multiplied by C, like that. Everything divided by 2 times 1, 2 times A. So this will give negative 5 plus or minus. When you work out whatever is in the square root, you will get that one to be 7225. 7225, then you divide by 2. So this gives negative 5 plus or minus. The root of 7225 is 85. And then you divide this by 2. So you'll have two values of X. The first value of X will be negative 5 plus 85 divided by 2. And then the second value of X will be negative 5. When you consider the negative, 5, this is over 2. So let us look at the one that we're going to consider. This one will give us, the first one will give us 40, and then the second one will give negative 45. So we shall ignore the second one, because here X represents the number of people, the number of members, and therefore we are not going to consider negative 45. We shall consider only 40. Because of course the members can't be negative. So therefore we are supposed to find the value of X. So X is 40. Those are 40 members. So those are 40 members. Now part 2, determine the percentage increase in the amount contributed by each remaining music club member. Each remaining music club member due to the switch. So we are going to consider the original amount contributed by each music member before the switch. So before the switch, it was 7,000 each member was supposed to contribute before the switch, divided by X. And then after the switch, it was 7,000. After they left, some 5 members left. So we need to get what is the contribution here. So it will be 7,000 divided by 40, and then after the switch it will be 7,000 divided by 40 subtract 5, that will be 35. So this one gives the amount to be 7,000 divided by 40, that will give 175 shillings. And then after the switch, this will divide by 35, that will give 200. So you can see now the increase. You can see the increase. After the switch, they had to pay 200. Before the switch was 75. So we can get the percentage increase. Which will be given by, so percentage increase will be given by increase divided by the original multiplied by 100. So the increase is from 175 to 200. So just get the difference, that is the increase, divided by the original. The original is 175, that is before the switch, and then everything here you multiply by 100. So when you work out this one very well using the calculator, 200 subtract 175 divided by 175 multiplied by 100, you'll get 14, and 2 divided by 7%, and that is the percentage increase, and that is how you're supposed to solve that question. Question 19. This is a question on income tax. The question reads, the income tax rates of a certain year were shown in the following table. So you have the table in monthly taxable income, Kenya shillings, then the tax rates are in percentage. So all the slabs are given there. In March that year, Judy's monthly earnings were as follows: basic salary 104,644, house allowance 25,000, commuter allowance 12,000. Judy was entitled to a monthly tax relief of 2,400. Part A of the question, calculate 1 Judy's taxable income that month. So we start with that. How do we get taxable income? We get taxable income. Taxable income is obtained by taking the basic salary plus all the taxable allowances. All the taxable allowances. So the basic salary is 104,644. 104,644. Then plus the allowances, we have 25,000 plus the commuter allowance, which is 12,000. Actually, you're adding all these. They're there. And these should give 141,644. So that is how you're supposed to solve that part. Part 2, the tax payable by Judy that month. The tax payable by Judy that month. So after getting the taxable income, which is 141,644, that is what now we need to tax using the taxation bands that are here. So we are taxing 141,644. So we go to the first band. The size of the first band is 0 to 24,000. So the amount there is 24,000, first band. So first band, we have 24,000, and that is taxed at the rate of 10%. These should give a tax of 2,400. Tax of 2,400. Then the second taxation band, we are supposed to get the size. This is how you get the size of that band. So 32,333 subtract 24,000, not 2401, and the size of that band will be 8,333 when you subtract. So that is the size of that band. So the amount to be taxed there is 8333. 8333. And for that band, the taxation is the rate of 25%. Is 25%. So when you tax these 8,333 times 25%, you'll get a tax of 2083 and 25 cents. Remember, this is the amount that you're taxing. You're taxing this amount. So on this side, you have the taxable income, this side, and then that is where we have the tax. So far, we have taxed 24,000 plus 8333. So you can get the total and see how far we are in arriving to this value, 141,644. We have to tax the whole of that amount. So far, we've taxed 24,000 plus 8333. When you look at the third band, definitely we may not go beyond that band, because when you look at the size of that band from 32,334 all the way to 500,000, the salary here cannot, the taxable income, when you look at our taxable income is 141,644, you not go beyond there. So the rest of the amount will definitely fall here in the third band. The taxable income is 141,644, and you can see the largest amount in that tax goes up to 500,000. So let's get the amount in this band. But now it seems not all the amount will fall into this band. So as per the size, that is from 32,334 to 500, if you get the size of that band, we don't need all that amount. So what we'll do, we will first check what we have already taxed. We check. I will do it separately here. So far we have taxed 24,000 then plus 83.33. So first we need to get that so that we can see this will give 32,333. So this is the amount we have taxed in the first two bands. So the rest will fall in the third band. So what is remaining? So to get the remaining amount, we shall take what you're supposed to tax, which is 141,644, and then we subtract 32,333. This will give us the amount that is remaining, and the amount will be 109,311. So this is the amount that falls now. This is what is going to fall in the third band. So we have 109,311, and that band is being taxed at the rate of 30%. The rate of 30%, like that. So now when you add 24,000 plus 8333 plus 109,311, that should give you 141,644. By doing so, we will have taxed everything. Now the tax that you get when you multiply these, you will get a tax of 32.93 and 30 cents. So that is what you get. Now from there, we can now get the gross tax. We get the gross tax after adding everything here. These are the taxes. So when you add 2,400 plus 2083.25 plus 32.93 and 30 cents, that should give us the gross tax. When you add that, you will get 37, tax of 37, 276 and 55 cents. So that is what you get. Now remember, we need to get the tax payable by Judy that month, so we need to get the net tax, also known as the payee. So to get the net tax, we less the relief. We have the relief as 2,400 is a monthly tax relief. So we get we subtract that 2,400. So when you subtract that, now we will end up with the net tax of when you subtract these, we get 34,876 and 55 cents, and that is the solution. That is the tax payable by Judy that month. We go to part B. In July that year, Judy's basic salary changed, her allowances and monthly tax relief remaining as before. Her net tax that month was 39,483 and 35 cents. Calculate her new basic salary. We need to get the new basic salary. So what you're given here is the net tax. So we will do some form of backward taxation here. So from the net tax until we go back and get the basic salary. So this is what you're going to do. Remember that how do you get net tax? Net tax, you get it from the previous question. You take the gross tax and then you less the relief. When you less the relief, when you subtract the relief, you get the net tax. So for this one, because we are moving backwards, given the net tax was 39,483, we will start by getting the gross tax. And the gross tax, we will get it by taking the net tax, which is 39,483 and 35 cents, and then we add the relief since it had been subtracted. For you to get the net tax, you take the gross tax, then you less the relief. So we add that, which is 2,400, and these will give this one. When you add these, you get 41. You get 41 883.35, that is at 5 cents. So this is what we need now to work with. Now, how do you get this gross tax? Of course, we use the taxation band. So the first band, the amount there we had was 24,000, and then we're getting this one from here. Look at the first band. That we're going to use part 2, A part 2, 24,000 times 10%. Times 10%. That one gives us a tax of 2,400. And then the second band, the amount was 8333 times 25%. This gives 2083.25. So we just following these. We want to see now, because we are doing what we call backward taxation. Now these two, remember this column, we have the tax. This is the tax. This is the gross tax, and these are side, these are the two taxes. So we have 2,400 plus 2083.25 from the two bands. These will give 4483 and 25 cents. So far, first and the second band, we have this tax. This is the tax. So the remaining tax will go to the third band. So now we have this tax here. So the remaining tax, because we have to get this. We have to get this tax. So 41,883 and 35 cents. We subtract the taxes from the first two bands, which is here 44,83 and 25 cents. So what is remaining will be 37,400 and 10 cents. This is the tax that goes in the third band. So 37,400 and 10 cents. That is the tax. So that now when you take these, the taxes, now when you take these tax, when you add 2,400 plus 2083 and 25 cents and 37,410 cents, when you add these, it should give 41,883 and 35 cents. So now what we don't have is the amount of money that was taxed in order to give this tax. So that band is taxed at the rate of 30%. So 30%. So there is an amount here that was taxed at this band. We call this amount X. We don't know this amount. And when it was taxed at the rate of 30%, that is when you get this tax. So let us get this amount. So you know how to get these. So X will be given by, we take 37,410 cents times reciprocal of visa 30 over 100. This will be 100 divided by 30. You can solve this. This is just an equation of x times 30 over 100 is equals to this. So you just solve for x, and this one gives the amount that you're going to get here will be 124,667. So that is the amount. This is the amount that was taxed, 124,667. So this is the amount that was subjected to this tax in order to give this amount. Now that one will help us to get the basic salary, because with this information, with these three bands, we can get the taxable income. And how do you get the taxable income? The taxable income is represented by 24,000 plus 8333 plus 124,667. So it is given by 24,000 plus 8333 plus 124,667. So these are the three that you're adding: 24,000 plus 8333 plus 124,667. And this one, when you add, is going to give 157,000. So that is the total taxable income. The total taxable income. Then let's go back now. The taxable income now will help us get the basic salary. Why? Because taxable income is obtained by taking the basic salary plus all the allowances. That is how we get it. So now, because you're getting the basic salary, so the basic salary will be given by, we take the taxable income of which we have it, then we subtract the allowances. So the taxable income, which is 157,000, and then we have two allowances. We have two allowances, 25,000 and 12,000. 25,000 and 12,000. And this gives, when you subtract this using a calculator, you get the basic salary of 120,000. So that is how you're supposed to solve that question. Question 20, part A. The following table shows the values of x and some values of y for the curve y is equals to 5 plus 10x minus 2x squared minus 4x cubed for x is less than or equal to 2 and x is greater than or equal to -2. Complete the table by filling in the missing values of y. You're supposed to complete that table by filling the missing values. So this is how you do it. Just use a calculator, and in your calculator you only need to feed these. You have y. The first one is 5 plus 10x. When x is -2, we are starting with this. When x is -2, simply substitute that in that function. Subtract 2, then x is -2, you square that, then subtract 4, then x is -2 cubed, like that. And that is exactly what you're supposed to do in the calculator. Feed the way it is, even the brackets, and then once you do that, you simply press equals, and that one should give you 9. That should give you 9. So the same thing applies to when x is -0.5. So y will be given by 5 plus 10. X is -0.5. So just substituting where there is x in this function, substitute it with the -0.5. Then subtract 2 -0.5 squared, then minus 4 -0.5 cubed. Just feed it the way it is, even the brackets in the calculator, and when you press equal sign, this one is going to give you 0. So that is what you do for all the others. That was just for demonstration. So that is what you do for 0.5. You simply substitute where there is x, substitute that, and you're using the calculator to do that. So it is not a very complicated process. Now when you feed in 0.5 in the same function, you going to get 9. Then when you feed 2 using the same process, you will get -15. So that is how you get the 2 marks, by just using the calculator and being very careful when you are substituting the values of x. Part B of the question: on the grid provided, draw the graph of y is equals to 5 plus 10x minus 2x squared minus 4x cubed. Use the scale. This is very important. You're supposed to use this scale. 2 centimeters to represent 1 unit on the x-axis, and then 2 centimeters to represent 5 units on the y-axis. You are supposed to be very strict. Strictly use the scale that is given. So I'll just demonstrate how you're supposed to do this with the graph that is already drawn, and then I will explain every step, how to plot, how to use this scale. So let's go to the graph, what you're supposed to have. So let me first go to the scale. You're supposed to use 2 centimeters to represent 1 on the x-axis. 2 centimeters to represent 1, you can see. So these are 2 centimeters to represent 1, like that on the x-axis. So that means 1 centimeter will be representing 0.5. So 2 centimeters are representing 1. That is how you're supposed to do it. And then for the y-axis, 2 centimeters to represent 5 units. 2 centimeters to represent 5 units, as you can see on the y-axis. So this is 1, 2 centimeters, 5. So you have 5. So that means 1 centimeter represent 2.5. With that, you need to know the size of one small square. The size of one small square. Let me start with the x-axis. So on the x-axis, what will be the size of one small square? So 1 centimeter, as you can see on the x-axis, represents 0.5. So, and there are 5 small squares. So 1 small square represents 0.1. Then on the y-axis, we said 2 centimeters represent 5. So that means 1 centimeter will represent 2.5. And then 1 small square, you take 2.5. Then within that square, there are 5 small squares. So these will give 0.5. So this is very important when you're plotting. You need to understand the size of one small square. Understanding the scale is the first thing, very important. Now after you've done that, now let's go to, you've drawn the axes and you have indicated the values. So let's go to plotting. The first point, -2, 9. When x is -2, when x is -2, -2 is here, y is 9. So 9 is there. So that is where 9 is. Make sure you understand the size of one small square. On the y-axis, it is 0.5. So 9 is there. Then we go to the other one, -1.5, -1. -1.5 is here. -1.5, -1. So -1, the point is there. Then the next one, -1, -3. So -1 is here, -3 is here, -3 is here. Then -0.5, 0, -0.5, 0, -0.5, 0. This is the point. Then 0, 5, 0, 5, 0, 5. When x is 0, y is 5. There is the point. 0.5, 9. 0.5 is here. 9 is here. This is the point. Then 1, 9. 1, 9. So when x is 1, y is 9 is there. And then 1, 9 is another one. 1, 9. 1, 9. 1, 9. I think we've plotted that. Then 0.59, I think we plotted that. 0.59. So 0.59, there is the point. Then 1.5 to 1.5. 1.5 is here. Then 2 is here. So 1.5 is here. 2 is there. That is the point. Then 2, -15. 2, -15. 2, -15. 2, -15. This is the point. This is the point. So after you have plotted these points, all these points, now it is time to join those points using a smooth curve. Now I want to explain something to do with this part. You can see this part. For this part, if you want to ensure that you are very accurate, because you're not supposed, these 2 points, you cannot join these 2 points using a straight line. You need to make a curve here. So what you do, you can always pick a point that is between 0.5 and 1. You can pick that, a point that is between 0.5 and 1. So when x, then you can fill that. So when x is 0 point, the point that is between, exactly between 0.5 and 1 will be, let me see, because it will be 0.75. So this is 0.6, 0.7 to be 0.75. The point that is exactly between 0.5 and 1 will be 0.75. So when x is 0.75, what is y? That will definitely give you this point that is here. It will give you this point that you'll be able to plot this point here. By doing so, you will have an easy time when you're drawing the curve. You'll need to just mark a curve. So you just introduce that point between 0.5 and 1, the point that is between there is 0.5. And then what do you use to get y value? You simply use the function here. Use this function. You just substitute when x, so this is a y is equals to 5 plus 10, x is 0.75 minus 2, 0.75, and then minus 2, 0.75 squared minus 4, 0.7 cubed. So that is what you use. So you simply substitute this value 0.75, and when you do that, you can do that, by the way, you can do that. So this will be 5. Let me see what you're going to get. So this is 5 plus 10 into bracket 0.75, close the brackets, then subtract 2, open the brackets, 0.75, that is supposed to be squared there, so you need to square these. You need to square these like that. So that one squared 0.75, square that, then minus 4, 0.75, and then get the cube of that. You get 9.6. So this will give 9.6875 approximately. You can plot 9.7. So this is the point. So 9.7 will be here. This will be the point. Actually, this will be the point. So x is 0.75, then y 9.7. So that is the point. Now that is how you're supposed to do it. Join this point using a smooth curve. Yours may not look like this exactly, but you need to ensure that the curve is as smooth as required. So make sure it is smooth with no sharp bends when you're joining. All right, so that is going to give you 3 marks. You get 3 marks for that. The first mark is for the correct use of the scale, then the other mark is for correct plotting, and the other mark is for the smooth curve drawn. So you get 3 marks for that. Let's go to the other question, part C. C part 1. Use the graph to solve the equation. Use the graph to solve the equation. So which graph are we using? We write first. The function that we're using is y is equals to 5 plus 10x minus 2x squared minus 4x cubed. That is the function that you're using to solve this. So what you do, you simply compare. So this is 0, write 0 there, and then we have 5 plus 10x minus 2x squared. I'm writing this function here, the one that you're required to solve, because we're using this function, minus 4x cubed. Then from there, you can subtract the two functions. Subtract the two functions. In y subtract 0 will be y. And then you notice the whole of this part, 5 subtract 5, 0, 10x subtract 10x, 0. Everything here, when you subtract, you get 0. So that is the line that you are left with. Which line is this? Y is equals to 0 is the equation of the x-axis. That is the equation of the x-axis. So this is how you do. Now go to the graph, and check the x-axis. The x-axis. Where does the curve meet? Where does the curve meet the x-axis? Check the point where the x-axis intersects with that curve. So this is one point, the other point, and the other point. So this will be the solution. So you read these. This will be the first solution here. You read this value that is here. So this will be negative 1.6. So that is the first value that you require. So x will be negative 1.6. And then we read the other one. The other one is here. The other one is this one. So that one is negative 0.5. So that one is negative 0.5. And then the last one, the last point is here. This is the other point. And that one is 1.6. That is 1.6. So that is a solution, 1.6. So these are the three solutions that you get from the curve. So you simply subtract the two functions. The line that is left, that is what you're supposed to check. You are left with y is equals to 0, that is the x-axis. Simply check where the x-axis intersects with that curve and read those answers. So don't worry about this. A slight allowance is always given. An allowance of plus or minus 0.1 is given. In some cases it is given. So in case you find very close answers to these, if you give yourself that range, plus or minus 0.1, then you can count yourself correct. Part 2, by drawing a suitable straight line on the graph, solve the equation. By drawing a suitable line on the graph, solve the equation. So again, we are using this function, y is equals to, this is the function of the curve, minus 2x squared minus 4x cubed. So again, compare these, this 0, then you have this is negative 3, and then this is minus 12x, and then this one is plus 2x squared, then we have plus 4x cubed. So you just compare this 0, negative 3, negative 12x plus 2x squared plus, then you can subtract these. Let me see whether subtracting is going to, yes, you can decide to think when you add, that will be the best way to eliminate most of these. Remember, you're trying to make sure you are left with the equation of a straight line, so you need to be very careful. So if I add the two equations, so y plus 0, you get y, then you have 5 plus negative 3, that will give 5 minus 3, that will give 2. So 10 plus negative 12, that will be 10x minus 12x, that will be minus 2x. And then negative 2x squared plus 2x squared, that is 0, that will be eliminated. Then negative 4x cubed plus 4x cubed, that one will be eliminated. And so we are left with the equation of a line. You're left with the equation of a line. If you would have subtracted, you notice that you'll be left with these cubes, and that will not give the equation of a straight line. Now with this equation of a straight line, you need to come up with a straight line. Draw a straight line using this equation, y is equals to 2 minus 2x. For you to draw this line, you only require at least 2 points. 2 points are enough. I will choose 1. When x is 1, just substitute here. 2 subtract. So 2 subtract 2 when x is 1. This will give 0. That will give 0. You're substituting x in this equation here. Then you can choose when x is negative 1. When x is negative 1, shall have 2 subtract 2, negative 1. This will give 2 plus 2, which will give 4. So these 2 points are enough to draw that line. So you just take this function, y is equals to 2 subtract 2x, then get 2 points. When x is 1, substitute 1 in this equation, y is equals to 2 minus 2x, get the value of y. Then plot these, 1 0, 1 0, y is 1 0, 1 0 is here, that is a point, 1 0, and then negative 1 4, negative 1, negative 1 4 is here. So these are the 2 points that you're going to use. So using this point and this, just draw a straight line and then make sure you extend that by using a ruler. Draw a straight line passing through these 2 points. And by doing so, ensure that you extend it so that it cuts that curve. Then after that, after you draw that line, you always write the equation of that line against the line. And then we need to see now, where does that straight line intersect with this curve? It intersects with the curve at this point. There is the first one, the second one, and the third one here. So what you do, you read the x coordinates of the point of intersection. So this is what you're going to do. So the first point is this. So you drop down and read this point here. You read this point that is here. You read the x coordinate of the point of intersection. So 1 is here. So this one is negative 1.9. This point is negative 1.9. So the first one will be x is equals to negative 1.9. And then the other value of x. The other value of x. So the other point where the line intersects with the curve is this one. So again, you draw a straight line and read the x coordinate of this point. Read the x coordinate of this point. So read the x coordinate of this point. So this one will give you negative 0.25. This point here, the x coordinate of the point of intersection, that is what you're reading. So this will give you negative 0.25. Negative 0.25. And then we have the last point. The last point is this one. This is the other point of intersection of the straight line, the curve. So you read the x coordinate. This one, you have to read the x coordinate. So the x coordinate goes straight, just straight. Ensure you go straight up like that. And when you just draw a straight line up, this point here will be, the x coordinate here will be 1.6. This will be 1.6. The point there is 1.6. So the point is 1.6. 1.6 like that. So that is how you're supposed to solve that question on quadratic graphs. Question 21. The following figure represents a cuboid. A cuboid is there. Line PQ is equals to 19 centimeters, QR is equals to 16 centimeters, and RW is equals to 4 centimeters. Points M and N are the midpoints of lines UT and UV respectively. So you can see the diagram there. First question, calculate the length of line RM. The length of line RM. So let me draw the line that you're supposed to calculate the length. There is the line. Look at that line. Look at all the sides that are going to help us. So what is going to help us to get the length of RM? First of all, we shall get the projection of RM, the projection of RM on the base, which is PQRS. The projection of RM is simply the shadow of RM on the plane PQRS. So that is going to help us, and the shadow of that line will be somewhere there. To be somewhere there. And then from there, we shall draw the shadow of M. The shadow of M will drop straight down there. So you can see the point of intersection of that line that you've drawn. These will form a right-angled triangle at this point. Let me name this point as X. So you can see we formed a right-angled triangle MXR. So that right-angled triangle is going to help us calculate the length of RM. We have this side. This side is 4 centimeters. Also, this one is 4 centimeters. Now we can get XR. So let's get XR. How do we get XR? We shall use triangle XSR. We can see that triangle RSX. That triangle is right angled at S, and we have this side as 19 centimeters. SR is equivalent to PQ, and then we have since M is the midpoint, and then X will also be the midpoint because we just drop straight downwards here. So X will also be the midpoint of PS, and PS is equivalent to QR, which is a 16. So if X is the midpoint, this will be 8 and this will be 8. So you can see in that right angled triangle that you have constructed, that you have drawn there, XSR is a right angled triangle, and you have this side and you have this side. So what you're missing is the hypotenuse. The side that is opposite the right angle, this is the hypotenuse. So how do you get the hypotenuse? We simply use Pythagoras theorem for that, and we shall get it by taking 19 squared plus 8 squared. Because this, when you work it out, is going to give you 19 squared plus 8 squared, then get the square root to give you 20.62. 20.62 centimeters. So this is 20.62 centimeters. Now let's go back to the triangle, where now we'll be able now to calculate the length of RM, since for this triangle MXR we now have two sides. So MR will be the hypotenuse. So MR, using Pythagoras theorem, will be given by, we have this side which is 4 squared, that is MX, then plus XR, 20.62 squared. Again, work out this one using a calculator, and this is going to give you exactly 21 centimeters. You get 2 marks for that. So that is the length RM. Part B, calculate correct to 2 decimal places. 1, the angle between RM and PQRS. Now this is the angle between a line and a plane. In this case, the line is RM, then the plane is PQRS. So let us identify RM. RM is there, we've drawn it, and then we have the base, that is a plane, PQRS. So to get the angle between a line and a plane, we do get the angle between that line and its projection, and its projection on the plane. In this case, we shall get the angle between RM, that is the line, and its projection. The projection is the shadow of that line on the plane PQRS. And we already identified the projection to be RX. Look at that line, RX. Here is the line, this is the projection. This is the projection of RM. So the angle between this line RM and the projection is this particular angle that is here. So this is the angle that we need to calculate. So we shall use that right angle triangle. We shall use the right angle triangle that we have there. So look at that right angle triangle MXR. So we shall get this angle by using trig ratios, and we can use any suitable. And let me use a tan. So tangent of that angle is given by the opposite side, which is mx, which is 4, then divided by adjacent side, which is xr. xr is 20.62. So that is how you're supposed to do it. So from there you can simply get the required angle. So how do you get that angle? You get the tan inverse of both sides. Tan inverse of tan of theta will give theta. Then we get the tan inverse of 4 divided by 20.62. When you get the tan inverse of that, that will give 10.98 degrees. That is correct to 2 decimal places. So that is how you get the angle between a line and a plane. And the line in this case is RM, the plane is PQRS. And you said you get that angle by getting the angle between that line, that is RM, and its projection on that plane. And the plane here is PQRS. We go to part 2. The angle between lines RM and MQ. So the line that you're missing there is MQ. So let me draw MQ. So MQ will be this one. That will be the line. So we have the angle between the two lines, MQ and MR. And the angle that we need is this angle that is here. So this is the angle that we need. This will be the angle between those two lines. Now, one observation that you make is that MQ, when you look at this diagram very well, MQ is equivalent to MR. Those lines are equal. When you look at them very keenly, you notice that the lines are equal, MQ and MR. So they are equal. You can put that mark. So if I extract it, that triangle here, you will have something like this. You'll have something like this. So we have MQR. So M is here, Q is here, then R is here. So these one have dropped a perpendicular from, I've actually dropped a perpendicular from M to meet QR at this particular point that is here, this point here. And this of course will form 90 degrees. So that I have already extracted that triangle MQR, so it is here. And since we have this side, we already got this one as 21. This is 21 centimeters, and therefore it is equal to this. This will be 21 centimeters. And then we have QR. QR is 16. QR is 16. Therefore, this one being the midpoint, this will be 8, and this one will be 8. So we just need to get one of this angle, and then we multiply by 2 to get the whole of this angle, because those two angles they're equal. So how do you get that angle? angle theta, I can use a sine. So sine of that angle theta that is here is given by the opposite side, which is 8, divided by the hypotenuse, which is 21. So that angle theta, you get it by getting the sine inverse of you get the sine inverse of 8 divided by 21, and these will give 22.39 degrees. So that is just one of these angles. Now to get the whole of these angles, because there are two angles that are similar, we multiply by 2, and these will give 44.79 degrees, the two of them. So that is how we get that angle. We go to part 3 of the question. The obtuse angle between planes PM and Q. PM and Q. I'll have to draw that. PM and Q. PM and Q. So we have PM, PM, then we have N, and then we have Q. Just be very keen with that figure. So we have P, M, N, Q. Look at that plane. And then we have MNWT, MNWT, MNWT. So you can see those two planes. It's good to look at those two planes, and to get the angle between them, look at the line of intersection of the two planes. The two planes are intersecting along this line, and therefore the angle between them, and which is we require to get the obtuse angle, is this angle that is here. This angle that I'm going to mark here. So this angle is what we require. That is the obtuse angle. Look at the planes again. P, M, N, Q, and then we have M, N, W, T. So the two planes are intersecting along this line. So this is where the angle will be made, where the two lines are intersecting. And when you look at it from the other side, you notice that this will be the angle between the two planes, this obtuse angle. Now the easier way to get that angle is by considering this triangle QVN, and then we get this angle that is here. Once you get this angle, because this one is a straight line, this one is a straight line, automatically when you get this angle, we'll be able to get this one, because the sum of angles on a straight line is 180. So getting this angle here will be easier, because we shall use this triangle here that is right angled here at V, and we have this side as, let me extract it here. So we have this side as I have to extract it here. Like that, eh? So the angle that you need is this angle. So you need to get this angle here, and this is 90 degrees. So from the figure we have VQN. This is V, this is Q, and then this is N, like that. So look at it again, VQN, and see it. So we have this side as 4, VQ is 4, VQ is 4, and then VN, N is the midpoint, so that will be half of 16, that will be 8, VN will be 8. So with those two sides we can get the angle. So how do we get this angle? We can use a tangent. So tangent of theta is equals to opposite side, which is 4, divided by adjacent. So this is the same as tan of theta is equals to half, and theta will be given by tan inverse of 0.5. 0.5 is the same as a half, and this will give 26.57 degrees. 26.57 degrees. Now once we get that, because now we have this angle 26.57, we can get now this one, because we just need to take 180, then subtract 26.57, and whatever remains will be this angle, which is 153.43 degrees. So this angle here, 153.43 degrees. So that is how you're supposed to solve that question. Question 22. This is a question on probability. A bag contains 5 balls randomly numbered 1 to 5. The balls are identical except for the color. Part A of the question. 2 balls are randomly drawn from the bag, one at a time without replacement. Part 1. Draw a probability space to show all the possible pairs of numbers on the 2 balls drawn from the bag. You get 2 marks for that. So you're required to draw the probability space to show all the possible pairs of numbers on the 2 balls drawn. There are 2 balls that are drawn, and then the bag contains 5 balls, and they are numbered 1 to 5. They're numbered 1 to 5. So because there are 2 balls that are drawn, to get the probability space, I will draw a diagram that looks like this, whereby we shall have the first pick. This one will represent the first pick on this side. So the first pick, and then this one is the second pick. So they are numbered 1 to 5. So 1, 2, 3, 4, and 5. So this is what you're going to get. Like that. So for the second pick, we also have 1 balls numbered 1, 2, 3, 4, and 5. So that is the first thing you're going to do. So the 2 balls, so the first pick is represented on this row, then this column here, second pick. So there are those ones that we are not going to consider that will be uniform. Like for this one, you'll get 1, 1. So we're not going to include this one, where we shall have the 2 having the same number. 2, 2. We have 1, 1. We have 3, 3. We shall not consider these, because the reason why you will not do that is because these balls will have the same number. They will bear the same number, the ones that I'm blocking here. The first one here, as you can see, you have 1, 1. This one we have 2, 2. We have 3, 3. We have 4, 4. And then we have 5, 5. You see, this bag contains balls that are numbered 1 to 5. And then you're picking 2 balls from the bag, one at a time. 2 balls, one at a time. So that means when you pick the first one is 1, you'll not have any other one. If you pick the second one being you pick the second pick 2, you not have any other 2. So that is why I've blocked this, because that one will not be considered where we have the balls having the same number. Now the outcomes now that we need to identify is here. We have the first pick, you get a 2, ball number 2. Then the second pick, you get a 1. Then the next one, you get a 3 in the first pick. Then you get a 1 in the second pick. You get a 4 and then a 1. This one is a 5 in the first pick, then a 1 in the second pick. Then we have a 1 and a 2. We have a 3 and a 2. We have a 4 and a 2. We have 5 and a 2. Then we have 1 and a 3. Then we have 2 and a 3. Then we have 4 and a 3. Then we have 5 and a 3. And then we go to the other one, the first one being a 1, the other one a 4. The first pick, you get a 2, and then a 4, 3, a 4, and then 5 and a 4, then 1 and a 5, 2 and a 5, 3 and a 5, 4 and a 5. So all those are the possible outcomes that you can get, and that is what we refer to as the probability space that shows all the possible pairs of numbers on the 2 balls drawn. So that means, for instance, just to explain the first one here, that means the first pick, you get a ball numbered 2. Then the second pick, you get a ball numbered 1. The first pick, you can either get a 3, and then the second pick, you get a 1. That is just what you need to understand. Now, after you've done that, let's go to part 2. Find the probability that both the numbers on the balls drawn from the bag were greater than 3. Find the probability that both the numbers on the balls drawn were greater than 3. So you will go to the outcomes and check where we have the 2 numbers and they are greater than 3. The 2 numbers on both balls, where, in what instances are they greater than 3? Let's go to the first row here. We don't have any. You can see here we have 1. The moment you have 1, that means that one, the whole of that row is disqualified. Both numbers should be greater than 3, and also here we don't have any. So the first one will be this one, where we have 5, 4. So let me list it here. So you'll have 5, 4, that is 1. So from here you can see that both balls must be greater than 3. So 5 is greater than 3, 4 is greater than 3. Then the next one is this one, 4 and 5, 4 and 5, 4 and 5. Both numbers are greater than 3. So of all the possible outcomes, and you need to count all the possible outcomes, all these outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have a total of 20 possible outcomes. So of all the 20 possible outcomes, the one that gave us greater than 3, both balls where we have greater than 3, are only 2 instances. So 5 and 4 and 4 and 5. So this means there are 2 out of the total outcomes, and these you can simplify to be 1 divided by 20 as the solution. Then part 3, find the probability that the sum of the 2 numbers on the balls, does not exceed 6. So what does it mean when you say does not exceed 6? That means it should be less than or equal to 6. That is what we mean. It should not exceed 6. So that means it should be less than or equal to 6. So let's go to the probability space diagram, and then we check all the instances where we have the sum of the two numbers on the balls being less than or equal to 6. Less than or equal to 6. We count them, less than or equal to 6. So we have the first row here. We have 2, 1. All these, they are less than. When you take the sum, 2 plus 1, that is 3. 3 plus 1, that is 4. 4 plus 1. So you can see all these qualify. They are less than. So 2, 1, 3, 1, 4, 1, 5, 1. Let's write that. So how many are those? Those are, so let me list them. 2, 1, 3, 1. So 2, 1, 3, 1, 4, 1, 5, 1, 5, 1, and then the other row we have instances where we have less than 6. We have 1, 2, 3, 2, and 4, 2. 1, 2. So we have 1, 2. 1, 2, 3, 2, 3, 2, 4, 2. 3, 2, 4, 2. So for 5, 2, look at these. For 5, 2, this one is going to give a sum of 7. 5 plus 2 is 7. So that one is not qualified because we need less than or equal to 6. That one gives 7. So it is out. So the next one is 1, 3, 2, 3. 1, 3, and 2, 3. 1, 3, and 2, 3. 1, 3, and 2, 3. 1, 3, 2, 3. So 4, 3 gives a sum of 7. 5, 3 gives a sum of 8. Out. So the next one is 1, 4, 2, 4. 1, 4, and 2, 4. 1, 4, and 2, 4. 1, 4, and 2, 4. 3, 4 will be out. 3 plus 4 will give 7. This one will give 9. It is out. It's not less than or equal to 6. Then for this row, the only one that qualifies here is 1, 5. 1, 5. 1, 5. 1, 5. So all these are the outcomes that are going to give a sum of the two numbers being less than or equal to 6. So we count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all these are 12. So the probability will therefore be 12 divided by 20. And 12 divided by 20, you can simplify these by 4, 3, by 4, 5. So you can, this one simplifies to 3 divided by 5. We go to part B. 3 balls in the bag are green in color and the rest are red. Determine the probability that the 2 balls drawn in A were one of the same color. So 3 balls in the bag are green. So the green, 3 green, and the rest are red. So how many of these are red? The rest. Remember, this bag contains 5 balls. Contains 5 balls. So if 3 are green, the rest are 2 to give a total of 5. And these are the ones that are red. Determine the probability that the 2 balls drawn were of the same color. We are going to draw a tree diagram to represent these. This one will represent the first draw. So we have green, we have red. This is the first draw. That branch represents the first draw. Then the second draw, green, red. Green, red. So this branch here represents the second draw. So now when you draw it like this, it represents the two balls that are drawn. So this branch here represents the first ball, and then this one the second ball. And then it is important to note that these balls are drawn without replacement. Without replacement. So that means when you draw a ball, that one is gone and is going to affect the total. So the total number of balls are 5, 3 greens and 2 reds. So the probability of picking a green will be 3/5. Then the red will be, there are 2 reds, 2/5. So the first pick you pick green. So now the greens reduces. They are not 3. Once you do the first pick, if the first pick is green, so when you're picking the second time another green, you'll find 2. The greens will be less by 1. So now they will not be 3, they will be 2. And then the total will not be 5, it will be 4. Then the reds remain to be 2, but the total has changed. When you go to the other branch, the first pick you picked a red, so the greens are not affected. The greens are 3. What is affected is the total. They are not 5, they are 4 because you've picked. Then the first pick red, so the second pick again red. So the reds are going to, when you're coming for the second pick, the reds will not be 2 because the first time you picked a red and there were 2. So the second pick you'll find 1. 1 out of the total. It will not be 5, there will be 4. So that is how we do it. So you have green, green. That the first draw is green, the second is green. The first draw is green, the second is red. Then the first is red, the second is green. Then the first is red, the second is red. With that tree diagram, now we can answer the question, where do we have the probability that these balls are of the same color? So probability of the same color means probability of green, green, or same color, or red, red, the same color. And you know the law of probability, or you're going to add these. So green, green, we multiply this branch 3/5 times 2/4. Then or, I mean, you're going to add these red, red, and that is 2/5 times 1/4. Simple as that. And this gives 6 divided by 20 plus. This will give 2 divided by 20. And this gives 8 divided by 20. And when you simplify this one, you get by 4. This will give, when you simplify, to give 2 divided by 5. So that is how you're supposed to do it. Part 2 of mixed colors. The probability that the two balls drawn were of mixed colors. So all the mixed colors is the ones that are left. So mixed color means it will be green, red, or red, green. As simple as that. Mixed colors. So we take this branch, green, red will be 3/5 times 2/4, like that. Or red, green, we have 2/5 times 3/4. Multiply these will give 6/20 plus this will be 6/20, which will give 12/20. When you simplify 12/20, this will give by 4, 3 by 4. Alright, so this will give 3 over 5. Alright, then there's another way still you can get these, a simpler way. You can also say that the probability of getting the two balls being of the mixed colors, because you already got the probability that the balls will be of the same color, you can say this will be 1, the total probability, subtract probability, they will be of the same color, because what you'll be left with is simply the two of these. When you subtract, you take 1, that is the sum of the whole probability, and then you subtract the probability that the two balls will be of the same color, that is green, green, and red, red. You'll be left with the 2 here. So this will be 1, subtract 2 over 5, because you got the probability here, they are the same color, and this will still give you 3 over 5. So this is just another easier method of working out the question. That is how we're supposed to do that. Question 23. Triangle A double prime B double prime C double prime is the image of triangle ABC under transformations T1 given by the matrix 2.5, 0, 0 and 1, followed by T2 given by the transformation matrix 1, 0, negative 1.5, negative 1. Triangles ABC and A double prime B double prime C double prime are also drawn on the following grid. So as you can see, both of them are drawn there. Part A, 1, on the same grid provided, draw triangle A prime B prime C prime, the image of ABC under transformation matrix T1. So you're drawing on the same grid A prime B prime C prime, the image of ABC under that transformation. So this is what you're going to do. When you are transforming any object using a transformation matrix, we do pre-multiply the object with the matrix of transformation. So in this case, the matrix of transformation is given here as, so it is given as 2.5, 0, 0 and 1, and we are transforming triangle ABC with that matrix in order to get A prime, B prime, C prime. So we get the coordinates of ABC. From the figure you can read the coordinates. So A is given by 2, 4. You just read the coordinates. A 2, 4. Then the coordinates of point B 2, 2. The coordinates of C 4, 3. 4, 3. So now we multiply these. The matrix of transformation T1 should come before. So you know how to multiply these. So row 1, column 1. So we have 2.5 times 2. I think I need to expand these. Let me try to expand these so that you can be able to see the workings clearly. So we have row 1, this row, we are multiplying this row multiplied by this column first. So 2.5 times 2, 2.5 times 2, then plus 0 times 4. Then we go to row 1, column 2. So we take 2.5 times 2, 2.5 times 2, plus the next one is 0 times 2. So 0 times 2, like that. That is the second column. Then that column, row 1, column 3. So you have 2.5 times 4, 2.5 times 4, plus the next one is 0 times 3. All right, so here we shall have A. This one will give A prime, B prime, and C prime. We go to the second row. Second row, row 2, column 1. So 0 times 2. 0 times 2 plus 1 times 4. Like that. We go to row 2, column 2, 0 times 2. 0 times 2 plus 1 times 2. Like that. Then from there we go to row 2, column 3, 0 times 4. 0 times 4, then plus 1 times 3. 1 times 3, like that. So now from here we can give now the coordinates. So the first one for 2.5 times 2, this one will give 5. Then here we shall have the first row. This one will give 5 as well. And then this will give 10. Then the second row, this will give 4. This will give 2. And then this one will give 3. So that is A prime, B prime, and C prime. So that is how you're supposed to do that. So you're supposed now to draw these. You're supposed to draw these. So A prime, 5, 4, 5, 4, 5, 4. So 5, 4 will be here. That is A prime. And then B prime is 5, 2. B prime is 5, 2. So it will be here. And then C prime will be 10, 3. 10, 3 will be there. And then you join these using ruler. So join the points, and there you have the triangle. So there you have the triangle. Now after doing that, we go to the next question. So the next question reads, this is part 2. Describe fully the transformation represented by matrix T1. You're supposed to describe this type of transformation that is here. This is the transformation that you're supposed to describe from ABC to this. So what has happened? When you're describing the transformation, you need first to know all the common types of transformation, and then you try to relate them one by one with whatever you're seeing in the diagram. Now, not all transformation are going to apply here. I'll just focus on the common ones that might be possible in this case. Let me start with rotation. This can't be a rotation, because for a rotation, you can see that, look at A and A prime, A and A prime, then B and B prime, C, and so these points have not been rotated. They have actually been moved. A has been moved to that point, C has been moved to this point, B has been moved to that point. So for rotation, that one is out. It can't be a rotation. Let's think of an enlargement, because it's confusing. You can look at these two triangles and you can try to imagine of an enlargement. This one, when you look at it first, you'll think that it is an enlargement, but that is not the case. Why is it not an enlargement? Simply because for an enlargement, there is always a center of enlargement. When you try to locate where the center is, you may not be able to identify exactly where the center is. Then for an enlargement, all the points move along a straight line from the center of enlargement. All the points move along a straight line from the center of an enlargement. And actually, if you join A and A prime, then join C to C prime here, then B, you notice all those lines have nowhere they're going to intersect. A prime, C prime. So for an enlargement, this might not be the case. Another reason this one will not be an enlargement, look at the point and look at the scale factor. For an enlargement, there is always a scale factor of an enlargement, and that is a very strong point to disqualify these, since when you take for instance A prime, B prime, and you try to get the length A, B, you notice this one is a constant. The length of AB is 2 units from 2 to 4. Then A prime, B prime is still 2. So this is actually not going to be an enlargement. It is one way, and for an enlargement, it's supposed to be all the sides are supposed to be enlarged. So when you look at AC, yes, it seems to have been enlarged. A prime, C prime. Then look at B prime, C prime, comparing it with BC, has been enlarged, but there's only one side that remains constant and has not been enlarged, and that disqualifies this from being an enlargement. In an enlargement, all the sides of this triangle are supposed to be enlarged by a constant scale factor. Now we are left with shear. Let's think about shear. Is there a shear? So what is a shear? So we know very well that under shear, the object's points move parallel to a fixed line, and that fixed line is what we call an invariant line. So when you look at these points, the object points, are they moving parallel to a fixed line? Which is this fixed line in this case, if this one is a shear? Because we know very well that all the points on the invariant line under a shear are moved. All the points on the invariant line do not move. But now, when you look at this one, we don't have an invariant line. There doesn't seem to be any invariant line in this case. Because for a shear, the points that lie on the invariant line do not move. But when I look at these two triangles, you notice that these points, all the points have moved. So it is very hard to identify the invariant line in this case. Another strong point that is going to disqualify these to be a shear is, look at the area of triangle ABC and the area of triangle A prime, B prime, C prime. That area, if you calculate the area of the object, this being the object and this one being the image, you notice that the area will automatically change. Under a shear, the area remains constant. The area does not change under the shear. It remains constant. This triangle, you can see the base is the same, 2 units, but the height has changed. And that will give a difference in the area. So with that point alone, that cannot be a shear. Let's go to a stretch. Is this on a stretch? Let's see, what is a stretch? In a stretch, points move perpendicular to the invariant line. Points move perpendicular to the invariant line. And when you look at these two objects, the object and the image, you notice that all these points are moving parallel to the x-axis. Look at the direction A to A prime, look at A to A prime, look at B to B prime. So this direction is actually all the points are moving parallel to the x-axis. With the y coordinates, the y coordinates are not changing. Just look at a few examples here. The y coordinate, look at the y coordinate of A, it is 4. The y coordinate of its image A prime is 4, has not changed. Look at the y coordinate of C, it's 3. Look at the y coordinate of C prime, still 3. Same to B, same to B prime. So this one is actually a stretch, because for a stretch the objects move parallel to a fixed line, and this time round these points are moving parallel to the x-axis, with the coordinates, the y coordinates, remaining unchanged. So we can say that this type of a stretch is that type whereby the points are moving parallel to the x-axis with the y-axis invariant. With the y-axis invariant, meaning that all the y coordinates are remaining the same. So that is the first proof that this one is a stretch. And then another property of a stretch is that there is always a constant scale factor. There is a scale factor. I want you to look at the point. These are A to A prime. Just look at that. So this is this length here, and then you can look at C to C prime there. So we can try to take for example, to get the scale factor, we take that length A prime, C prime, and then divided by AC. We can take that and see. So this is 1, 2, 3, 4, 5. That is 5 units. And then AC is 2 units. I'm counting the squares. From A prime to C prime, how many squares are these? 1, 2, 3, 4, 5. 5 units. And then AC we have 2 units. So this gives a scale factor of 2.5. We can check with another side still. We can check with another side, which is, let me see whether we can check with another side here. So if you take, for instance, BC, B prime, C prime, B prime, C prime, divided by BC. So this one will give 1, 2. This is 1, 2, 3, 4, 5. Still, this one is 5. And then BC, we have 2 units. 2 units. So this one will give you 2.5. The one that will not give you the same is when you take A prime divided by B prime. And the reason, because this movement is parallel to the y-axis. And you know, for a stretch is always one way. It is one way. So you can see, because we said that this is a stretch parallel to the y-axis with the y-axis invariant. So that is why you can see, because these points are lying on the AB. Look at AB and A prime, B prime. Those points or those lines are parallel to the y-axis. And for the y-axis, we say that one is the invariant line. So that is why you can see they remain the same. Another thing you're supposed to note is that under a stretch is one way. The stretch happens one way, parallel to a given direction. And that is why you can see all the other lines have been stretched apart from only that one that lies parallel to the y-axis, which is the invariant line. And that line is AB and A prime, B prime. So I think that one is enough. So there is a constant scale factor. it is given. And then another point that you can use to support that this is a stretch is that the stretch changes the area. The stretch changes the area. When you look at ABC, triangle ABC, and look at triangle A prime, B prime, C prime, you can see the area has changed. And for a stretch, the area changes. Then for the shape can slightly change, but of course, it still remains to be a triangle. Unlike for Russia, you always find the shape is distorted, where the area is preserved. Under the shear, you always find the shape is distorted, whereas the area is preserved. But under a stretch, the area changes and the shape is somehow preserved. Because when you look at these, you cannot say the same shape because the angles are going to change. But you can see, you will notice that these are triangles. So therefore, to describe these, how to describe the stretch, you must give the stretch factor, because you have to mention that this is a stretch. So it is a stretch. It is a stretch. And we've said when you're mentioning about the stretch, you must say it is parallel to which direction? Stretch that is parallel to the x-axis, with y-axis, invariant. And then the scale factor of the stretch is 2.5. That one is fully described. B part 1. Find the single transformation matrix that maps ABC to A double prime, B double prime, C double prime. So we want to get the single matrix of transformation that maps these to these. So that one undergoes two types of two transformations. And when you look at the first statement here, triangle A double prime, B double prime is the image of ABC under transformation T1 followed by T2. So you can see we have ABC. It is transformed to A prime, B prime, and then to A double prime, B double prime, C double prime. So ABC undergoes T1 followed by T2. So this is successive transformation. And to get the single matrix for successive transformation, because we have the two, T1 followed by T2, we do get the single matrix of transformation under successive transformation by taking T2 multiplied by T1 and not T1, T2. It is very important to note this. Under successive transformation, T1 followed by T2, we get the single matrix of transformation by taking the matrix T2 multiplied by T1 and not T1 multiplied by T2. So let's get T2 multiplied by T1. T2 multiplied by T1. So T2 is 1 0 1 0 1 0 negative 1.5 negative 1 negative 1.5 negative 1 like that, and then T1 2.50 0 1. That is what you're supposed to multiply. So let's multiply these. Row 1, so we take row 1 column 1, so 1 times 2.5, 1 times 2.5 plus 1.5 times 0, negative 1.5 times 0, and then we take row 1 column 2, so 1 times 0, 1 times 0 plus negative 1.5 times 1, negative 1.5 times 1, like that. We go to row 2, So row 2, column 1, 0 times 2.5, 0 times 2.5 plus -1. Let me see. Oh, we're here. 0 times the -1 times 0. -1 times 0. And the last one, we have row 2, column 1. So 0 times 0. 0 times 0 plus so this one and this 0 times 0 and then -1 times 1. -1 times 1. So this will give 2.5, and then when you add these, you'll get a -1.5. Then this one will give 0, and then this one will give -1. That is exactly what you're supposed to get as the single matrix of transformation. The last part, determine the area of triangle A double prime, B double prime, C double prime. So we are going to use triangle ABC. We get its area, and then that will help us to get the area of this triangle. One concept that you're going to use is very simple, that the determinant of the matrix of transformation is equivalent to the area scale factor. And how do you get the area scale factor? It is the area of the image divided by the area of the object. So that is how we get the area scale factor. We take the area of the image divided by the area of the object. So this concept is very important. That is what you're going to use. So we'll need to use the matrix that transforms ABC to A double prime, B double prime, C double prime, of which we've just identified. That matrix is 2.5, 0, -1.5, -1. So this matrix, so once we get the determinant of that matrix, and you know how to get the determinant, take the product of this diagonal, which is 2.5 times -1, subtract the product of the other diagonal, -1.5 times 0. So this will give -2.5, subtract 0. So we will get a negative determinant. Now when you get the negative determinant, we just say that the determinant is equivalent to area scale factor. And since we're getting the area, we are going to consider the absolute. The absolute of 2.5. Why? Because for the area, because you're going to ignore the negative. So we take the determinant to be 2.5, because the area of an object can't be negative. So we consider the absolute value of 2.5. So we take the positive only. So the determinant is equals to the area scale factor, which is equals to 2.5. I've explained why I've ignored the negative. So now, how do we get the area of the object? The area of the object is very easy to identify. The object is triangle ABC. For that triangle, we can calculate the area by simply using a half base times height. So the area of ABC, so area of ABC is equals to a half times the base. The base is AB, those are 2 units. Then times the height is this distance here. This is the distance. Still that one is 2 units. And this will give the area as 2 square units. That's the area of ABC. So we can now go ahead and get the area of the image. So the area scale factor is given by the area of the image, which is the area of A double prime B double prime, C double prime divided by the area of the object ABC, which is 2, should give us the determinant, which is the area scale factor, and that is 2.5. So getting the area of A double prime, B double prime, C double prime, you're going to simply multiply both sides by 2. So you get 2.5 times 2, and this gives 5 square units. So that is the area of triangle A double prime, B double prime, C double prime. That is how you're supposed to solve that question. Question 24. The following figure is a sketch of the curve whose equation is y is equals to x squared minus 4x plus 3. The y-intercept of the curve is at y is equals to 3, while the x-intercepts are at x is equals to 1 and x is equals to 3. The region bounded by the curve, the line y is equals to 3 and the line x is equals to 3, is shaded, as you can see in the diagram there. At A, 1, evaluate the integral from 0 to 1. You're supposed to integrate x squared minus 4x plus 3 with respect to x. So let's first carry out this integration. So this is how we're going to do the integration. So you integrate x squared with respect to x, that will give x cubed divided by 3. When you integrate 4x, you will get 4x squared divided by 2, that will give 2x squared. When you integrate 3 with respect to x, you get 3x. Don't forget to add the constant of integration. Then square brackets, you are integrating from 0 to 1. From there, the next step, you substitute 1 in x. So whatever you have x, you substitute it on with 1. So you shall have 1, this 1 cubed divided by 3, subtract 2, 1 squared plus 3, 1, and then the constant. You don't need to indicate that constant because it will get subtracted, but it's okay if you put it, there is no harm. And then from there, you can substitute 0 in x. So you shall have, in place where you have x, you can substitute with 0. So you have 0 cubed divided by 3 minus 2, 0 squared plus 3, 0, and then plus the constant. The next step, we can simplify these. 1 cubed divided by 3, that is a third. Then subtract, these will be 2, then plus 3 plus the constant, like that. Then subtract, this will give 0. Everything here will be 0 plus c. Everything here will be 0, 0, 0 plus c. From there, you shall have a third subtract 2 plus 3. A third subtract 2 plus 3 will give 1 and a third. A third subtract 2 plus 3 will give that, then plus the constant. Then you subtract c when you open this bracket. So these will give 1 and a third, and that is the solution for that part. Then you go to part 2. Calculate the area of the shaded region above the x-axis. Above the x-axis. So you can see the shaded area above the x-axis. So for that one, you will identify this shape. There is a shape here that is, this is a square. This is a square. We'll get the area of this square here. You can see that square that I'm indicating. And then we subtract this that is here. We are going to subtract this area that I'm shading here. This area. You're going to subtract these. Once you do that, you'll be left with the shaded area above the x-axis. So we'll get the area of that square. I can name this square for purposes of understanding. this, remember this is 0, I can name these A square, A, B, C, and D. You get the area of that square A, B, C, D, and then subtract this area that I've shaded here. Subtract that area, you'll be left with the shaded area above the x-axis. Now, how do you get the area of this square? You can see from here, from this point, there is 0 to 3. So those are 3 units. Those are 3 units. Then again on the y-axis, from 0 to 3. That is why I say these are square. The square of sides 3 by 3. So the area of the square, which is 3 by 3. And then we subtract this area that is shaded here. Now, which is this area? We need to be very careful here. This area I've shaded here is the area under the curve. It is area under the curve y is equals to x squared minus 4x plus 3 between 0 and 1. And if you look keenly, that is what we have calculated in the first part of the question, A part 1. When you integrate this function, x squared minus 4x plus 3, that is the function of this curve, from 0 to 1, that gives the exact area under the curve y is equals to x squared minus 4x plus 3 from 0 to 1. So this is actually the area that you have calculated from the first part, and that area we calculated it and got it as 1 and a third. That is very important. So we subtract 1 and a third. So this will be 9 subtract 1 and a third, and this gives 7 and 2/3 square units. Part B of the question, calculate the area of the shaded region below the x-axis. The shaded region below the x-axis, which is that area. You can see this area. It is the area bounded by the x-axis between 1 and 3 and the curve, this curve that is here. So how do you get this actual area? By simply integrating the function of this curve between 1 and 3. So that is how we get the area bounded by this curve and the x-axis between 1 and 3. So let's do that. So we shall integrate. We integrate from 1 to 3 the function of that curve, which is x squared minus 4x plus 3 with respect to x. So we have already integrated these, so you get x cubed divided by 3. When you integrate 4x, you get 2x squared, then 3x plus the constant. Then this is from 1 to 3. So from there, we substitute 3, but there is x, substitute that on with 3. So we have 3 cubed divided by 3, subtract 2. This will be 3 squared plus 3 plus the constant, like that. And then we substitute now 1, where we have x, substitute with 1. We have 1 cubed divided by 3 minus 2, 1 squared plus 3, 1 plus the constant. Once we do that, we can simplify these. We get this is 27 divided by 3, we get 9. Then 2 times 3 squared, that is 9, that is 18. Then plus 9, then plus c, like that. Then we already substituted 1 in the previous part. Look at this part here, we substituted 1 here and we progressed like this. We got 1 and a third plus c. Once you substitute 1 here, it is already done here, we did it here, 1 and a third plus c. So the whole of that, the whole of these will be 1 and a third plus c. Let's open the bracket. So we have 9 subtract 9 9 plus 9, that is 18. The whole of these will give us 0 plus c, and then we subtract 1 and a third, subtract c. So this one will give negative 1 and a third square units. Now we are not going to leave the answer like that, because it's not possible to get a negative area. The negative only implies that the area that you are calculating falls below the x-axis. That is the meaning of that negative. The negative implies that the area falls below the x-axis. Otherwise, when you're writing the answer, take the absolute area. That means the area with only positive sign. So you write it as 1 and a third square units. Part C, calculate the area of the entire shaded area. The entire shaded area. So the area above the x-axis, we got it here as 7 and 2/3. 7 and 2/3. And then the area that is below the x-axis, which is 1 and a third. So when we add these, it will give 9 square units. So that is what you're supposed to do. By simply taking the area, the shaded area above the x-axis, you got that. Then add with the area below the x-axis that is shaded, and you get the solution. And that is how you're supposed to solve that question.